So we want to switch gears a little bit, and the lights kind of indicate that already. We really want to kind of now look at the future and get some feedback from you of what you think is important, what are some of the issues that we should address and that we maybe don't, or that we should emphasize more, or that we look at it from a different angle. And to start that out, I have 5 slides, actually 6, sorry. And then I hope that we can actually start a dialogue and we get some feedback from the audience and bring them in. And so I'll highlight some of the ideas that Dee, Paul, and I have talked about, and they'll clearly have our academic and disciplinary bias. So there's a lot of other things that obviously can be brought into the equation. One of them, again, focusing on the density management studies, one of them I want to point out is the idea we have the opportunities to look at issues across scales. That came up a few times. We can look at from the microplots to transects, from the riparian area to the upland areas. We can look at treatment areas, at sites, and as you see here, the context around those sites within the landscape changes. You know, the first thinning entries on these studies was a thinned area in a sea of unthinned stands. Now those studies look like the control is the unthinned areas in a sea of thin stands around it. So the larger scale issues have changed. And of course, you know, whether the benefits of thinning when you think across scales probably be quite different if you're thinning the very first stand in your district or the very last stand in your district on that. The large-scale studies really provide some opportunities to look at variability. You know, we have focused a lot on average responses, and of course that's what scientists do with ANOVAs. But it really allows us to kind of move back and saying, what kind of variability do we create, especially when you throw in the practical implications of skid trails and things like that. And the last component that we kind of looking at interesting future issues is the whole idea that we have a spatial context to consider, and we have documented the space. So we're looking at things like, if within upland, do the trees in the riparian buffer notice? Do they get a benefit from increased water that is not taken up? You know, Kenny Zika is working on that. Those kind of issues come up. The second set of issues from a scientific point of view, we manage structure. And usually, I guess, at least in my world, we measure the structural response. But we're not really after structure. We're after the processes and functions and ecosystem services that those structures provide. And so making that link, when you look at songbirds that are found in a certain forest of a special structure, if within, do we see another set of songbirds come in that key in on that structure, or is there a delay? Is there a disturbance effect? Is there a spatial issue that overrides this structure-function relationship? Our preliminary data with Sveta's work show that it's not as straightforward that, you know, you build it and they will come. That's not the way it necessarily works for all species. The third one of my special interests, actually, I'm sure all of you have bought the book in the audience. I should make the pitch here. Is the idea of resilience and adaptability on that. That is really, to me, one of the key issues down the line. You know, the one thing that is certain in the future is that we have more uncertainty. But I'm not certain about that either. So, but looking at preparing the ecosystems that they can react to surprises and respond in a way that fulfills the desired ecosystem goods and services, you know, from clean water to habitat to timber. So one example is here that we've gone through and basically grouped all of our understory species by certain ecosystem functions, in this case related to wildlife habitat and food aspects of wildlife habitat. And then we kind of look at each one of these groups and say, how would they respond to certain changes in the environment, in this case related to climate change, of course, that's the catchy topic. And so if we're thin, do we increase the probability that those insect pollinating function and the associated food chain is maintained or increased under climate change conditions? You know, the spatial scale of those studies allows us to look at that. Those kind of issues, I think, bringing those into the managed landscape, into the thinning studies is key and certainly of interest to me. The last one here, one of the nicest slides you'll see here, if I can get an Oscar for the best visual on that. this is really tying actually Paul's and Didi's and my work a little bit together. Again, Kenny is involved in that as well. We're kind of using water almost as a linking agent on that. We're looking at water as it affects tree growth in that. We're actually looking at isotopes, detecting water stress in the past and what thinning does to altering water stress. Then linking that to the stream flow, to the habitat conditions in the stream and the aquatic insects and amphibians, linking that also to the understory vegetation, to the palatability of the understory vegetation, and then, of course, providing food for browsers and other aspects on that. And, of course, tying it into the fish component, so kind of morphing from these individual studies more into a systems view and trying to pull things together. And that, of course, ties to what Didi already pointed out. That's the kind of basis we need that then will allow us to look at, can we look at, again, preparing ecosystems for climate change? Is there migration corridors as one example, how that kind of information can be used? So that's the last visual. I'll go back to the best slide of the day on that. But I'd really like some more feedback, and maybe Paul and Didi if you have something else, but really looking at the audience, anything else you think is worthwhile to bring up and to discuss?
With tree growth, but an interesting element that he's looking at there is also retrospectively the variability we've had in climate over the life of that stand and the interaction of climate variability with our treatments. And so climate change is on the table, something that no one's talked about over the last 2 days, but it's one of those emerging topics that we need to be talking about into the future. A couple other things that came to my mind that we haven't talked about in the last 2 days but are on the table. We've talked a lot about the forests and the commodities and the values in those forests, but we haven't talked about the forests as being a source of water for human populations, and that'll be something that comes to the forefront over the next several decades. Forests are not just producing trees for people. Forests are going to be producing water for people. And in the Northwest, we are going to be one of the premier water producers for the Western United States. That hasn't really come to the forefront, but it will be coming to the forefront in the next 20, 30 years. And so as we're looking at thinning prescriptions and riparian buffers, it's not just for habitat and species. It's going to be for human commodities as well as we go into the future. So that forward thinking for the commons that these areas provide for people will become increasingly more important. Another thing that hasn't come up that's strong in my mind is some of the natural disturbances that are strong in some areas. We haven't really seen in the west side yet, but it's going to come one way or another, and that's disease. And how does disease affect what we do on the landscape? And that could be in terms of tree diseases or other diseases to the ecosystem. So a variety of disease agents, or you might think of them as pest agents, need to be considered. These could be very large-scale disturbances or affect how we manage lands. And things like thinning prescriptions will come into play as we deal with those. A couple other just bullet points of things that came to my mind as I heard talks over the last 2 days. I heard about the tremendous value of these relatively large-scale studies, even though everyone has some surprises that happen or flaws in the implementation of a stand-scale study. Nevertheless, a lot of science, a lot of new information is coming out of each of them, whether they be DEMO, these are acronyms for the different studies, the REMS study in Western Washington, the DMS study in Western Oregon. Lots and lots of new information is coming out of each of these. And there's also a value of keeping some of these alive and addressing additional concerns. Something I heard about that's kind of on the table is as our stands are getting older, they're going to be hitting that 80-year age. And I think that there's a value to looking ahead and seeing what types of questions we have for manipulating stands greater than 80 years. Are they just in a hands-off zone, or do we need to be looking at experiments now in that 80 age plus category to answer questions that will need to be answered 20 years from now? So that's on the table. What should we do with those older stands in an experimental sense now to get answers that will be needed in the future? And then from Gordy's talk on, well, we don't need to do everything everywhere. Well, what comes to my mind is, well, how do we plan out landscapes so we do enough someplace? So for example, for salmon habitat, there's discussion of priority areas, priority watersheds for things like salmon, salmon strongholds across the landscape. And you might think of that for anything, owls, other organisms, or other values. But how much redundancy in terms of a conservation value? How many of those do we need? And we don't have very much science for that. So understanding how we might do the distribution of our values across large scales. If we're not having something everywhere, well, how often do we need it in some places? So those are just a couple things that came to my mind. I'm sure Paul has a few as well, and then we'll get yours.
I'll keep my comments brief. A lot has already been said, but there's two things that I think about, maybe two or three, that I still think are really important. And I stated one of those today about sort of the validity of modeling and the need for underlying data and information to support modeling. And I think I really want to make clear that I think those are really hand in hand. They're mutually beneficial, and they're certainly not mutually exclusive. We can't do it all with a model. Similarly, I oftentimes look at this multi-scaled aspect of our sciences and how do we link across scales. And I realize that most of the big policy decisions are going to be made at a landscape scale. That's where we have the big impacts. But in order to go beyond description and understanding process, we need to understand the underlying smaller scale processes that are driving some of those patterns. And so we can't really move away totally from sort of both the empirical basis behind models, and we can't move to the bigger scale in ignorance of what's going on at finer scale processes. And so I'd like to raise that point. And then also, I think one of the great challenges out there, working on these larger scale silvicultural studies, I don't feel like we've hit the right scale yet, especially if we're talking about all lands management and linking our population centers to our resources. I really like the large watershed point of view where we can actually link what's going on managed lands for natural resources, and can we identify the direct processes and linkages all the way down into those major urban areas or those community areas that are utilizing the resources. So I think there's still another scale of research that I don't want to call it a watershed assessment, but there's a scale of research that we're kind of not fully engaged in. I'm not sure that we can afford it, but I think it's something that we have to keep in mind is the value of our work will become enhanced if we can form some more direct linkages to the populations that we're actually providing resources to and services. So we wanted to open this up for some feedback, and it's been kind of a quiet meeting in terms of feedback from the audience, and we really like to hear what people are thinking out there. So I invite anyone out there with statements, questions, whatever, feedback to please step forward and have at it.
So here, I'll give you one. First of all, I want to reinforce what you just said, Paul, about the importance of long-term studies and its relationship to modeling. Some of the conversations I've had have involved we're basing models on 10 or 15 years worth of data and projecting them out 200 years. And the differences in assumptions make a huge difference in the end result. And if we can pursue some of these studies over the long term, I think they will tell us. The other one that I haven't heard addressed very much, because we don't think of it always in the West Side, is fire. And I guess one of the questions that occurs to me is, what do we do post-disturbance? In an area, say, that we're managing for historic range of variability in late successional forests, if we get a big fire and it burns everything up or whatever, how do we respond to that? And what were and are the historic pathways following disturbance, and how then shall we manage?
I was just talking to Bernard Borman in the hallway on Monday, and there will be some lessons learned about the Biscuit Fire coming out pretty soon, and I may get others to be asking that question a little bit more. So the Biscuit, of course, is in a different type of forest, southern Oregon, but I think some of the lessons learned there will be applicable to the entire West Side. And they were filming an OPB special, so it'll be going out into the public, I think, late winter, early spring, and so there will be opportunities to address that, I think, coming up pretty soon.
So maybe we need to be a little more controversial up here, but I don't really think, especially with the idea of future global changes, read the Journal of Forestry, there's some really good articles in there, the last one. But that the historical conditions will be that useful. The future will not be like it was in the past. We're going to have no analog conditions there that we haven't seen in the past before. So looking back, we can learn a lot. We can learn a lot about processes, but using that as a blueprint and target, as is done in many cases, I don't think is particularly useful in the past. In fact, it may just set up for exactly the wrong thing. Thinking about a lot of the old trees that we're trying, or forests that we're trying to mimic, started in the Little Ice Age on that. So they already maladapted as of today. So if the temperature increase keeps going, and we try to mimic something that started under different conditions, we're going to be way off target on that. I think we've got to shake ourselves loose a little bit from that. We need that flexibility that Gordon kind of pushed a little bit, and we need that focus on resilience and adaptability to work into the future. That get anybody going?
I think my comment has to do more with scale. As a manager, particularly with the BLM, we're getting a lot of questions about renewable energy sources. And in fact, I heard a professor from OSU talk about biomass for use in everything from commercial buildings to jet fuel. And I think that over time, federal forests are going to be more and more challenged with pulling products out, especially as other parts of the country, other parts of the world who have fewer environmental laws reach some kind of a threshold where it makes more sense for us to get energy supplies from within our own boundaries. So I'm wondering, I guess my question is there a way for scientists to step back and look at things at a scale that would help us understand general landscape health? I mean, are there ways to talk about big picture thresholds beyond which we as land managers need to keep in mind as more and more energy pressures come to the Pacific Northwest? Because I do think we have a unique set of resources here that over time are going to be more and more appealing to the country. So I'm just wanting, it's sort of that looking out, it's part climate change, it's part scale, but is there a way for us to work together, east side and west side, to keep in mind how much is too much, those kinds of questions.
What I noticed from the landscape ecologists that spoke here at this conference is that the state of landscape ecology seems to be developing very rapidly in response to technologies, and they're in a descriptive phase. They are out there describing what we have. They're not setting goals for what we should have. And somebody else will need to be stepping in to even describe what landscape health means. I don't think that concept exists right now. Ecosystem health, perhaps, but landscape health, I think landscape ecology is very descriptive, and it's not getting to processes and functions yet. So I think maybe linking ecosystem management to landscape health might be something that we could think about and do.
And it kind of brings the whole idea of thresholds and tipping points and nonlinearities. That's really, I guess, to me, part of that adaptability, resilience discussion. And that's really one of the key points to look at those at various scales, you know, from a stand when we lose some major component in terms of like stability or health to the landscape on that. And that's certainly one I know I've been thinking about pushing more to kind of investigate where are the thresholds, where are the tipping points, and then providing landowners with an array of options that you can work with within that acceptable range on that. And so as scientists, of course, we don't set the policy, but I think we can probably set the framework on that. And that's really where some of these studies with the variability, I think, come in handy, that we can look at that more rather than looking at average conditions. We can see certain conditions in certain parts of the stand that we feel like is pushing a tipping point, at least on the small scale.
Something else that comes to my mind, especially as we start expanding to larger scales and talk about landscapes, then necessarily we need to be talking about partnerships. And as we look across land ownerships, then of course BLM and Forest Service lands are in a gradient of public lands relative to the priorities that they have for their land management. And public lands need to be folded into that as well. We had lots of partners speaking at this conference, and we all are asking very similar questions. And so I think those partnerships are going to get more integrated as we go forward and as we look at larger spatial scales. It doesn't scare me too much that maybe the BLM is being questioned about, well, should they be the Forest Service? I know the Forest Service is also being questioned as like, well, what makes you unique, and are you redundant to other organizations, and do we need to put you together? Well, we already are together because we're asking the same questions and trying to do many of the same things on all of our lands. And so this partnership development, I think we've seen in our study, is a very strong thing. We've seen that for large-scale research, we can't do it without our partners. We can't do it without the site coordinators and people on the ground implementing the site. So science is running in partnership with the managers already. And I think the land managers will be running in partnership with each other to develop a scheme across landscapes to meet all these different priorities, whether they be jobs, commodity production, and commodities could be water, wood, or ecosystem values, which may be other conservation type things. To get all of this done, it's going to take a partnership. And I think that's something that we need to learn how to do better. We're not really taught how to do partnership development. But as we go to landscape scales, I think that's a social perspective that we need to develop a little bit further.